All right, so welcome, guys. Welcome. So let's join. We have physics. Okay, so today we want to look at elasticity. Elasticity, which is going to later take us to Hooke's law. So we have a lot of things to do today. So please let's join. Let's join. All right, so please, if you're set and ready, please can I get a thumbs up? If you're set and ready for the class, please can I get a thumbs up? Please just give me a thumbs up on the comment box. Just type let's go. Type let's go. Type let's go. I need the energy to be hot. Just type let's go. So in the next couple of minutes or at most 1 hour, we're going to be breaking down everything you need to know about this topic. And of course, you can go ahead to smash your. Yesterday I was supposed to drop questions for us, but to be very honest, it skipped my mind because after I dropped my phone, right, my phone was low, so I needed to charge it. So I'm going to be doing both of them tonight. So let's start. Now, we want to talk about elasticity, right? Elasticity, elastic component of a material or elasticity. Now, let's talk about elasticity. We all know what elastic is, okay? There is nobody that would say he or she does not know what elastic is. Elastic is anything that you can actually expand, or when you apply a force, it will expand. When you release the force, it returns back to its shape. So elasticity is the ability of a substance to regain its shape and size after being distorted, right? Elasticity is the ability, you have to take note of this, is the ability of a substance to regain its shape and size after being distorted by an external force. Okay? Now, let's say, for example, we have a spring. Let's say we have a spring. So let's say we have this spring. Okay, now this is a stand and this is a spring. We all know that spring has the ability to expand when you drag it, and it can retract when you release it. So there are any substance that has the ability to regain. If you drag this spring, you drag it, the spring will expand. When you remove the force or when you remove your hand, the spring contracts again. Okay, so any substance that has the ability to regain its shape and size after being distorted by an external force is elasticity. That's the definition of elasticity. Now, what is elastic material? So I can come here and say, now, elastic material, if elasticity is the ability, elastic material will simply be, now, remove this ability here. If you remove this ability, that definition gives you elastic material. Elastic material is a substance that can regain, let me write it out. Now, elastic material is any substance that can regain its shape after being distorted. Okay, your normal elastic, anything that when you drag it, you leave it, it returns back, that is elastic material. Now, there is a law in physics that actually helps us to understand or carry out calculations pertaining to elastic material, and that law is called Hooke's law. Okay, so if you see what we did, we started off with elasticity, right? We introduced elasticity to be the ability of any substance to regain its original shape, and we went ahead to say elastic material is any substance that can regain its shape. Now listen, there is a law called Hooke's law. Now this law is basically what is breaking this particular topic down such that we can carry out various calculations. Now it says extension of any elastic material. So let's use this spring for example. Spring is an elastic material. Extension simply means increase in length. If something was initially original length, sorry, if something was originally 15 cm, if something was originally 15 cm and then you stretch it and the length now becomes 20, it simply means that there is an extension. I'm going to use this to explain. Now let's say the length of this spring is 10 cm without any load. The heavier the load, the more stretched the spring would be. So extension is basically increase in length. So if this length was initially 10 cm and then so we now have so let's say you now put a weight on this spring and that weight drags this spring down. Basically, there is an extension. How will I know the extension? This length, let's say this length is now 15 cm. Now, how do you know extension? Extension is simply the new length minus the original length. Original length was 10 cm. Before this weight was placed on it, it was 10. After this weight was placed on it, it stretched to 15. So extension equals to 15 minus 10, which is equals to 5. So what this law is telling me is that this extension you're seeing here depends on the force. If I increase this force to 50, the length of this will increase more, provided this elastic limit has not been exceeded. So if you're dragging elastic, if you apply small force, the expansion you're going to have, right, will not be the same when you apply a great amount of force. So it's telling me that that extension, that is the increase in size, the increase in length, is what we call the extension. Okay? Initially, something is 10 meters. You drag it, it becomes 20. That is an extension. Okay? So that is what this law is trying to tell us. It says that extension of any elastic material is directly proportional to the applied force, provided the elastic limit of that material is constant or is not exceeded. First thing first, what is elastic limit? Everything has in life, we say, don't get somebody angry to the point that the person will lose his cool. There is always a limit for everything. For something to be able to act as an elastic, yes, there is a limit. If your polo, if your clothes is elastic, there is an extent you drag it and that stuff will lose its elastic ability. That means the clothes will no longer be able to return back to its shape. If you bring normal elastic and drag it, it will expand. But there is an extent you drag it to, that material will no longer be able to return back to its size again. So that is why we said the force. So if you put force here, this spring will increase. The more you're applying the force, the spring will increase. But this increment will continue provided that this spring still has the ability to return back to where it was. Okay? So that is basically the first introductory part of this. So I don't know if you have any questions. Sorry, I'm a bit under the weather. I'm having serious headache. So I just had to proceed. So please, if you have any question, let me know. First, we talked about elasticity, which I already explained. Second, we talked about elastic material. Third, we're talking about Hooke's law, right? Where I said Hooke's law says that the extension, what is extension? Extension, as the name implies, is, I'm not talking about extension we use in charging our phones. No. Extension in length simply means if the length was initially 10, you drag it. The increment in that length is what we call the extension. Extension is increment in length. So now look at this. There was no weight here. This guy was initially 10. The length of this was 10. We now place a load here. Once you place a load, for the fact that this is a spring, the spring will expand. That expansion will lead to increase in size or in length. And when you now measure this guy, you now have 15 cm. Right? Now, once you've gotten 15 cm, your extension will now be the new length, which is 15, minus the old length, which is 10, which is going to give us 5. So I'm going to come to check the screen. If you have any question, please just drop it on the comments. So mathematically, Hooke's law, now Hooke's law says that extension E is highly proportional to the force. That means the more you're applying the force, the more you're increasing the length of the substance. And in mathematics, anytime you have a proportionality sign, this is always replaced with equality sign. So this becomes so therefore K equals to F over E, which means you can have F1 over E1, F2 So this is basically the formulas we're going to be using to solve problems. But let me explain this again. Please, do you understand this explanation, or I should explain it again? I really want to be sure. Do you understand this Hooke's law explanation that I said? The more the force, because when something is directly proportional, direct proportionality simply means if you're increasing one, the other will also increase. If I increase force, extension will increase and vice versa. That is what it means. Okay, so please confirm if you really understand what I did here or you need more explanation. 1 minute, please. I need to check and also we can solve problems. Now let's look at some few examples. Question 1. A load of 5 Newton gives an extension of now we have this. They said a load of 5 Newton gives an extension of 0.56 cm in a wire which obeys Hooke's law. What is the extension caused by the load? Now, basically, I'm going to actually give us the schematic diagram of this so that you can see, as we are solving it, you can be imagining it. So let's assume this is, this stuff is roof of a substance. It can be the top of the house, and we have a wire. Let's call that, we can call it spring, it does not matter, right? Now, this is the original length. This is L0 original. Now, before load was placed. Now, we now have, when you now place the load, you place load of what? 5 Newton. Now, remember, the original length was L0. So this additional length becomes the extension, E1. And they told us that the E1 was 0.56 centimeter. Remember, without the load, this guy was E0. After placing the load, this was the original length. From here to here is still your L0. Now, when you now place the load, the spring stretches to cause an extension, which is increase in length. That extension was given to us to be this. That is E1. The load is F1. Now, they now said, what is the extension caused by a load of 20 Newton? So it's more like they are removing this 5 Newton and allowing this spring to return back, and then putting back a new weight of 20 Newton. So I'll come here and I'll say, I'm just showing us this. "20 Newton, this is F2. That is your F2. Now, do not forget that there is now a new extension here, E2, which is basically what they are asking us to find. And remember, there is a formula here. We have F1, 5. We have E1, this. We have F2, and they're asking us to find E2. Please look at this, then I'll solve. All right, more explanation. Please, let's make it practical. Now, class, let's make it practical. Now, this is a rubber band. This is a rubber band. So this is more like a rubber band, elastic material. This is an elastic material because if I apply force, it will expand. If I release a force, it comes back. Now, how much expansion this rubber band will go depends on the amount of force I'm using to drag it, which is same thing as load. If I actually tie a stone and put it on this rubber band, that stone will drag it downward. So we are saying that for you to carry out calculation under Hooke's law, this is a general formula. We have F1 all over E1 equals to F2 all over E2. Now this is the first formula you need. The next formula is F equals to KE. Because there are times that they can just give you F and give you E and you're asked to find K. But you cannot get E. E is an extension. F is force, initial force, and E is extension. So that one means initial, the two means final. So F1 is the initial force, E1 is initial extension. Now, what is extension? Class, you cannot get extension without knowing what the initial length was. Look at this rubber band. This is the original length of this rubber band, right? Without force. This is the original length. Okay. So let's say this rubber band. Let's say the original length of this rubber band is 2 centimeter. And we are tying this rubber band somewhere. 2 centimeter. Okay. Now, I now come here and attach a heavy stone on this rubber band. You will notice that this rubber band, if you attach a heavy stone to this rubber band will increase in length. Now, we now have, if I come here and I say this same rubber band, if I put a stone, it increases in length. Can you see that? The length increases. Now, the extension is actually the increment in length. The original length was 2. So anything on top of these 2 is as a result of the force that is dragging it down. This length is 2 centimeter. Okay. Now, the more force I drag this, the more increase the length becomes. So the increment in length, anything on top of this 2 centimeter is extension. That is why this law says that the force applied is directly proportional to the extension. That means when something is directly proportional, it means as you're increasing the force, you're also increasing the extension. I don't know if I'm making sense. I had to make it practical. Now, using this guy, for example, they said a load of 5 Newton gives an extension of 0.56. So let's say, for example, this is an elastic material. And I come here and I put a load of 5 Newton. And this stuff, let's say from here, was the original length, L original. But the moment you put this length, it stretches this guy down. So I can say This dotted line is the extension. So it from here to here now become 0.56, which is the extension 1. Or you can decide not to even do all of this in exams. Simply go straight to the formula to solve. Just come here and say, they said, provided Hooke's law obeys, provided it obeys Hooke's law. Let's just go straight to the point. Provided it obeys Hooke's law. In Hooke's law, what is the formula to solve Hooke's law? This or this. But the one you're going to use depends on the parameter given to us. The question says a load of 5 newtons, so this is F1 equals to 5, gives an extension of 0.56, E1 equals to 0.56. What is the extension? A new extension. What is? That means they are asking you for the new extension. Is E2. If it is caused by F2 equals to 20 Newton. Class, once you've written down the formulas, right? Remember, since they said Hooke's law, you quickly know that Hooke's law has these two formulas. Either this or this. But based on the parameters given to you, they gave us F1, they gave us E1, they gave us F2, and we are asked to find E2. So which of the formula are we going to use? This. Let's just go straight to the point. I was trying to illustrate, but there is no need for that. In Jamb, you don't need it. Okay? So this is the one I need because these parameters, out of the 4 parameters, they gave us 3. And they're asking us for just 1. So let's solve. So this guy now becomes, from here, I'll now say, so therefore F1 over F2 cross multiply. What I'm looking for is E2, which is this guy. So when I cross multiply, I now have F1 E2 equals to F2 E1. I cross multiply, F1 multiplies E2, F2 multiplies E1. Now what I'm asked to find is E2. So I want to make E2 subjects of the formula. That is, I want E2 to stand alone. So I will divide both sides by F1. So I'll say this becomes F1 F1 cancels F1. We now have F2. Now in exam, this is in exam, the best thing to do is to make what you're looking for subject of the formula before you start inserting your parameters. It reduces error and mistake. If you start inserting the formulas from here, you can make mistake and change numbers. But the moment you've actually done your subject formula, what you're looking for, put out the formula. So what is left for you is now to just say, what is F2? F2 is 20. What is E1? E1 is 0.56. What is F1? F1 is 5. 20 divided by 5 is 4. 4 times this, the answer becomes 2.24. Please confirm this answer for me and also confirm if you're following, because a lot of persons said they came late that I should explain again. Please, if you understand now, please indicate. Now, someone say, why didn't I change cm to meters? Now, because the option, Jamb is option, is not WAEC. The option was in cm. So since it is in cm, I need to keep using cm. So please, since it's very easy. Since you're in Jamb, everything has options. So whenever you're solving, what determines whether you're going to change it depends on the options that is given. If your answers are in centimeter, why do you want to change to meters? So if, look at this, these are the options, centimeter. So why will I want to change to meter when it's already given to us in centimeter? You can only change except maybe the options were in meters. Okay, so please take note of this. A lot of persons asked me this question or have been asking me this question. So you can, in this case now, there is an option. So you look at the option to know where you're going to put your final answer. Please, any question? All right, so let's look at the next question. All right, so we have the question here. The question says the extension in a spring. Extension in a spring. So I'll say solution. Extension in a spring when 5 grams weight was hung from it. Now, some persons might say, why are we using weight? Now, remember, weight is a force, all right, that is being acted upon by force of gravity. So, two things involved. It's either you convert this guy to weight, to force or weight, which is 5 times 10, multiply with acceleration due to gravity. But note that whatever you multiply with 5, you have to also multiply with 20. So instead of you to multiply 10, just leave it out, because if you do the multiplication, they will still cancel out, right? If whatever you do to the left hand side, you do it to the right hand side. So instead of you to say convert grams to weight of force, you just leave it like that, because if you're to convert this guy to force, you have to multiply by 10. If you're to convert this guy to force, you also have to multiply by 10. So why do you want to stress yourself in exams? You know, in Jamb, the more you increase the values, the more it's above your brain to carry out the calculation. But if the numbers are small, you can do like fast calculations and get your answer. But once you start multiplying big values, you must use calculator, and it becomes imperative for you to try as much as you can to avoid escalating your values. So the extension in a spring when 5 grams weight was hung from it is 0.56. So extension 1 is 0.56. Now force 1 is 5 grams or 5. Remember, even though this is grams, you'll still use this guy because if you were to convert this guy to force, you say times 10. Weight equals to mg. Force is mass times acceleration. Right? Now, weight is a type of force that is acting vertically. So the acceleration changes to acceleration due to gravity. So if you are to convert this 5 to weight, which is 5 times 10, you also convert this 20. So you're going to multiply this guy by 10 and multiply this guy by 10. You're still going to get the same answer. So instead of you stressing yourself, multiplying this guy by 10, why not just use it like that? Because whatever you're doing to this, you're doing it to this. So at the end of the day, they will still cancel out. I believe you've gotten what I mean here. Now, E1 is 0.56 cm, while F1 is 5. If Hooke's law is obeyed, very important, once you hear Hooke's law, quickly take your mind back to that two formulas I gave us, right? If Hooke's law is obeyed, it means that that stuff is an elastic material. It will always come back. If Hooke's law is obeyed, what is the extension? That is the new extension. If you now use a load of F2 equals to 20, remember we have F1 all over E1 equals to F2 all over E2. Once again, what are we looking for? E2. Remember, I already did that subject of the formula here. So I'm not going to do that again. So I'm just going to say, you're going to cross multiply and make E subject because this is what I'm looking for. I already did this in the previous case, but let me do it again. When you cross multiply, F1 multiplies E2 and F2 multiply E1. So therefore, E2 is F2 E1. So you now come here and say F2 is 20. E1 is 0.56. F1 is 5. Can you imagine? It's the same question. Can you imagine? The same question that they turn. So it tells you that Jamb repeats question. These are two different questions I took from the past question. But guess what? It's the same thing. The only thing they did is that here they gave us the 5 as Newton. And here they gave us the force as this one as Newton. So it's the same thing. Please, if you're following up with this, right, please write I understand. Type I understand. Let me be sure that you understand. Now let's look for another question that is not related to this. Please type I understand. Let me be sure you're following. Now, let's look at another question here. So I want to give us two questions as well for us to try. Now we have this. Okay. Now we have two questions. Now there are different ways question can be asked, but what I want to do now is to first of all allow this one to soak into our brain. If you follow me, you're going to love it. I would have just been scattering the questions here and there, and then you will now be struggling. Oh, how can I solve this? How can I solve this? But no, I've given us same nature of question 3 good times. Why? Because once I'm done, I'm not going to give us question on this one again. If you notice, we are using all of you notice how we are solving. It's almost the same. So I want you to, at the end of the day, be able to assimilate this into your brain. Then I will now look for a question that is disorganized and give it to us so that we can see how we can organize it and then get the answer. Now they have a question here. They said, the point beyond which a stretched spring does not return to its original length is called dash. Now remember, I made mention of elastic limits. Every substance has a limit that beyond that limit, right, it's no longer normal. Car has a speed limit. Car has a recommended speed limit. It means if you go beyond that limit, anything you see, you take. It's either you become a spirit or you're going to see a spirit. That is if you're driving car on a very high speed. Human beings have a limit, right? There is a limit to which somebody can take rubbish or nonsense. Once you exceed that limit, you now realize that that person that was calm was just calm because maybe for some reasons or the other. So elastic material, remember, elastic material is a one that when you stretch it, you leave it, it returns back. You stretch it, you leave it, it returns back. Now there is how I will stretch this rubber band to the point that when I leave it, it will not return back. Two things involved is either it will cut or it will not return back to how it was initially. So elastic limit of a material is the point beyond which the material loses its ability to return to its original shape and size. So the point beyond which a straight spring does not return to its original length is called dash. The answer is elastic limit. The answer is elastic limit. The answer is elastic limit. So make sure you don't cross people elastic limits. Because when you cross people elastic limit, you're going to see a monster that you yourself, you'll be scared of. Ah, I did not know you're like this. I did not know you can do stuff like this, because you have made the person to cross the line. All right, so let's clear up this space so that we can solve the question below. Okay, so they said, now this is actually Jamb favorite question. Like, it's, if you look to the past question, I'm getting it from past question, it's kind of repeating almost every year. A 10 gram of mass, remember, yes, they mention mass, but as long as it is acting downward, it is weight, because you can convert this guy to weight by multiplying it by 10. But just like I told us, you don't really have to use it like that. Okay, so I'll say this F1 is 10 grams. It was placed on a pan of a spring balance, which caused an extension of E1 5 cm. If 15-gram mass, which is F2, is placed on the pan, what is the new extension? E2. Still the same pattern and still the same concept. So you know what? I'm not going to complete this calculation. So the same pattern, F1 over E1, F2 over E2. Now make E2 subject of the formula. This becomes F2 over E1. What is our F2? 15. What is our E1? 5. What is our F1? 10. 15 times 5. Please press your calculator for me. 5 into here, 1. 5 into here, 2. 2 into here. So the answer should be 7.5 cm. Option C. If you're following, if you're getting value for the class, because I'm mentioning to the spirit now, I'm mentioning to the mood, please give me a thumbs up. That thumbs up, it makes me to know that you're following and you're catching up. Love from India. Love from Nigeria too. You're welcome. All right, Eniola, Ngozi, Abike, that's good to know. Now let's look at this next question. So we have a question here. Oops, 3 persons. All right, so let's solve this. Now, I'll try to see if I can solve this without a diagram, because in Jamb you will not have diagram. The total length of a spring when a mass of 20 is hung on it is 14. Solution. Note, total length is always equals to original length plus extension. So if the length of a spring is this, and you now put a load, let's say this length is 5, which is the original length, and you now put a load, and that spring becomes something like this. This now becomes the total length when a load is attached to it. So you notice that the spring was initially 5. So the total length will be this 5 plus this new extension. So whenever you hear total length, it is original length plus the extension. Okay? Take note of that. So original length, let's call it L0. Now, the first mass, which is force, is F1, which is 20 grams. Is hung from the end. Let me read out the question, then I'll come back and read it again one. The total length of a spring when a mass of 20 grams is hung from its end is 14 cm. Now, total L1 is 14 cm. What is the total length, which is L2, when a mass of 30 grams, F2? They say, okay, while its total length, now they say while, they did not say what. While its total length is 16. So the total length of a spring when a mass of 20 was hung is 14 cm. Now, while when you hang 30 cm, the total length becomes 16. All right. They now say calculate the unstretched length, which is the original length. Unstretched simply means the length of the spring without any of those weights. Okay. Now, but you remember that they said Hooke's law, but in Hooke's law, the formula for Hooke's law has no business with L at all. What we know for Hooke's law is F1 all over E1 equals to F2 all over E2. Now, for the first force, for L1 will be original length plus extension 1. This L1 is the total length when a force of 20 grams is attached. Now, for the second length, when a force of 30 is attached, it's still going to be L0 plus extension 2. Which means, for me to get my first extension, I will say L1, which is the total length when a force of 20 was applied, This now becomes L1 minus L naught, and this guy becomes L2 minus L naught. So anywhere we see E1, this is what we are going to put, L1 minus L naught. And guess what? What we are asked to find is original length, because it said calculate the unstretched length, that is the length that did not stretch. So what we are asked to find is L naught, and we can see this. So you come here and say F1 over E1 equals to F2 over E2. Anyway you see F1, you put 20. Anyway you see E1, you put L1 minus L naught equals to F2, which is 30. Anyway you see E2, you say L2 minus L naught. Now what is the value of L1? 14. 20 minus all over 14 minus L naught. What is L2? 16. If you notice, L naught is now the common stuff. This is what we are looking for. Okay? Now, in Jamb, anything that will make you, anything that can reduce the stress for you, do it. Class, you have 20 here. We have 30 here. So I can just cancel 0 from here, cancel 0 from here. It's the same because what I'm doing here, I'm doing it here. So this becomes 2 all over 14 minus L naught, 16 minus L naught. Cross multiply. This becomes 2, 16 minus L naught equals to 3, 14 minus L naught. 3 times 16 is 32 minus 2 L naught. 3 times 14, please let me press your calculator. 14, 14, 14, 12. Okay, that's 42. We have 42 minus 3 L naught. Now collect like terms. Collect like terms. Bring these 3 to this side and take 32 to this side. This 3 minus, this 3 L naught was initially minus. When it comes over to this side, it becomes 3 plus, becomes positive. This one comes over to this side, we have 42 minus 32. 3 L naught minus 2 L naught is L naught. 42 minus 32 is 10. So the original length, which is the unstretched length, is 10, which is the answer to that. If you have any question, please drop it on the comments. She's Grace. Where are you lost? All right, so this is what I'm going to do, right? It's already past our time. I'm going to solve this particular stuff with explanation in the group. So the paid group, please, this is one of the advantage of those being in the paid group, right? This class is free now, but additional stuff is for members. So for those that do not understand, yes, please write it down. I'm going to resolve this all over again, step by step, with voice note explanation, and I'll post the solving on the group. Right? It's just one of the benefits of for today's class, because we already passed 10 p.m. A lot of persons needs to sleep. All right, I wouldn't want to exceed 10 p.m. Okay, so we've actually done 70% of Hooke's law, 70%. The remaining 30%, hopefully, we're going to complete it in the group. So I'm going to resolve this step by step. Every question you've asked, I'll resolve. I know this question is that is why I said That was why I made sure that initial question, right? I solved 3 of that so that it will enter your head. Imagine I was, swapping question. I solve this, I solve this, I solve this. You will just be confused. A lot of us, you read like that. You will not focus on one. You will not understand one first. But you see what I did? I first of all solved the first part and you understood it very well. And I told you that the next one I'm going to give you will stress your head, and which is obviously what is I expected that, so it's normal. I didn't expect us to understand everything at once. But this is the only problem is that we're already behind time. So I would not like to continue again because I would just want to be at most we'll stop by 10:10, but this is already 13 minutes after 10. So guys, the rest will continue on WhatsApp. I'll solve this night. Once I drop, I'll power my phone because my phone is somehow low already. I'll power my phone, resolve this step by step, like step by step with explanation so that you understand it very well. Once again, if you're yet to sign up for our class, the premium class, so that you can join our group, please text me and then I will add you up. So all your questions will be answered. You can make part payments. You can actually drop payment to show commitment. Anything you have, you can drop to show commitment. All right, so they can take part in what is happening in the group. So I'll stop here today. Thank you very much for tuning in. Tomorrow is maths. I'll see you guys tomorrow. Yusuf. Yusuf says, I don't understand. Yusuf, you came late now. You came late, Yusuf Banki. You joined late. Chioma, please, I don't understand. Chioma, if you did not come late, no problem. Like I said, I'm going to re-explain again. Finally, NEPA have taken light. So good night, everybody.